Good morning. On this occasion we are going to solve exercise 3.7 from the SAIC Electrical Circuit Fundamentals book. Here they allow me to determine the voltage Vx, the resistance of 20 ohms. Now performing walnut analysis. Well, the first thing we need to look at, and it has a dependent current source. It has a value of 0.2 times the voltage Vx. Well, then, all this is a common node. It means that everything that enters at that point is equal to everything that leaves. Now, I'm going to pre-mark this point Bx, which is the same, right? And I'm going to analyze the currents coming in and the currents going out with a visual analysis, except that at that point 2 amps come in, and this current source comes out. It depends. Part of finalizing the direction of the currents in these resistors. Note that the polarity gives me a view of how this resistance is polarized, where the current that enters would be here and in this resistance, since I assume that the current also enters here. Now, I am going to call this current I1 and this I am going to call current 22, and I am going to do the analysis. First I'm going to locate them. I'm going to put the currents that enter into the equation, which would be the 2 amperes and how, and I don't see that nothing else enters at that point. This is going to be equal to the cogitas that come out to the I1 plus the I2, plus the 0.2 of B x with 0.8. Well, then I continue and the I1, because it is the tension B. Now, well, we know that all the equations are in terms of Bx. So, if I add all this, 1 out of 10, 1 out of 20, plus 0.2, I may have to score the same. 2 is going to be equal to 0.35 Bx, where Bx is going to be equal to 2 over 0.35, and that is going to be equal to 5.71 volts. That is the value of Bx. Bx